Hello everyone, welcome to my channel, and I have conducted a series of test design to evaluate the effects of losing 20% of amount of neurons of a transformer-based model. Here we designed a series of cognitive tasks ranging from mathematical problem to logical reasoning, and the outcome of the tasks are here. The first one is mathematical problem solving. The model was presented with a question about calculating average speeds of a train, and it successfully computed that the train traveling 60 miles in 2 hours has an average of speed of 30 miles, so it has passed this mathematical test successfully. And the second test is a language translation task. When asked to translate an English sentence into French, the model provided correct translations, and this showcases the model's ability to maintain its language processing capability in the face of losing 20% of neurons. And then there's a sentimental analysis test. The model analyzes the sentiments of the statements, I just love rainy days, they're perfect for reading a good book, and correctly identifies sentiments as positive. And this indicates that the model's ability to comprehend and analyze sentiments was not adversely affected by dropouts. And here, the logical reasoning. However, the models encountered difficulty with logical reasoning after losing 20% of neurons was applied. Prior to this test, the model could logically deduce that if all roses flower and some flowers fade quickly, it is possible to conclude that some roses fade quickly, but not 100% sure. However, after losing 20% of neurons, the model failed to provide correct logical reasoning for similar type of logical constructs. And this particularly outcome is of interest as it suggests that the application of losing 20% of neurons performance based on the nature of cognitive task. Logical reasoning, a task that likely depends on the intricate relationship between neurons and their ability to form complex associations, seems to be more sensitive to the perturbation caused by losing neurons, and this contrasts with tasks that involve more straightforward computation or memorization, where the model's performance remains unaffected. And here's a summary of our final experiments. The x-axis shows the percentage of the neural connection disconnected, ranging from 0% to 50% in increments of 10%, and the y-axis represents the model's accuracy percentage, which is starts from the 100% with a complete model, and finally represent to unusable with 50% of neurons lost. And here we can see that with decrease of neuron actually being put into use, the accuracy of the model are decreased faster, which means that with more and more neurons are damaged, the model are generally become unusable.